lesson, we're going to prove the summation of C where I runs from 1 to n is equals to nc. Suppose the summation of C where I runs from 1 to n, where n is an element of integer and c is an element of a real number. By the definition of summation, we can write as the summation of C where I runs from 1 to n is equals to c plus c plus c plus c plus c up until the nth term.
So we are adding the constant value c a total of n times, so we can rewrite it as nc. So therefore, the summation of c where I runs from 1 to n is equals to nc.
Okay, so today we will prove to you that the summation of CA sub I, where I is equals to 1, or runs from 1 to n, is equals to C times the summation of A sub I, where I runs from 1 to n. So the proof is, suppose the summation of CA sub I, where I is equals or runs from 1 to n, where n is an integer and c is an element of real number. And a sub 1, a sub 2, a sub 3 until a sub n is a number sequence. By the definition of summation, the summation of CA sub I, where I is 1 to n, is equals to CA sub 1 plus CA sub 2 plus CA sub 3, CA sub 4, so on and so forth until CA sub n.
So then we factor out the common term c in each term in the sum. So we have here c times a sub 1 plus a sub 2 until a sub n.
And by definition of summation, a sub 1 plus a sub 2 plus up until a sub n is equal to the summation of a sub I, wherein I runs from 1 to n. Thus, we have c times the summation of a sub I, where I runs from 1 to n. Therefore, we have proven that the summation of c times a sub I, wherein I runs from 1 to n, is equal to c times the summation of a sub I, wherein I runs from 1 to n. Therefore, we prove this statement.
Good day, everyone. Today we're going to present a short but important proof in mathematics, the linearity of summation. So this property tells us that the sum of the sum of terms from two sequences is equal to the sum of each sequence individually.
So we will prove this by today, which is the summation of quantity a sub I plus b sub I, where I runs from 1 to n, is equals to the summation of a sub I, where I runs from 1 to n, plus the summation of b sub I, where I runs from 1 to n. So in proof of this, we use the definition of summation. By the definition of summation, we can rewrite this as the quantity of a sub 1 plus b sub 1 plus the quantity of a sub 2 plus b sub 2, so on so far, until the quantity of a sub n plus b sub n. And after we get this, we use the association and commutative properties of real number addition. Then we regroup and rearrange the terms. We will get this, the quantity of a sub 1 plus a sub 2 until the a sub n, and plus the quantity of b sub 1 plus b sub 2 until b sub n. And by the definition of summation, we can get this, the quantity of a sub 1 plus a sub 2 until a sub n is equals to the summation of a sub I, where I runs from 1 to n. Well, the quantity of b sub 1 until b sub n is equals to the summation of b sub I, where I runs from 1 to n. Therefore, we combine two of them. We can get this. That's our conclusion, we successfully proved this. That's all. Thank you.